All right, here's the second half of 4.1. So what happens when we start to have fractions and word problems with our systems of equations? So we still have our three ways to solve them: substitution, elimination, or a graphing calculator. Graphing calculator is awesome, but I will make you do it all three methods on the test. So make sure you practice them all. So what am I going to do when I'm looking at this one here? Well, I don't like fractions. So I'm going to multiply each equation separately by a common denominator so that I do not have fractions anymore. And this is legal because it's an equal sign, an equation. So look at this first one. I'm going to times this whole thing by 3 over 1 or 3, and that will eliminate both the 3's in the denominator. And the bottom one just happens to be a 3 also. They don't usually match, but they did on this one. Okay, I'm going to switch my pen to black, and let's go ahead and multiply that. So when I multiply 3 by 2/3, the 3's cancel, and I get 2x. When I multiply 3 by y, here, I get 3y. I mean, 3 over 1 is 3y. So, and then the last one, again, the 3's cancel, and I'm left with equals -5. Much prettier equation. Okay, second one, 3 times x is 3x. Minus 3, the 1/3 times 3 is 1. So it's 1y or y equals -13. Okay, so just timesing that by 1, 2, and 3. So these are our new two equations, and this is a grouping symbol here that means set, but these are our set of new equations. So right now, if I try to do elimination, these would add to 5, and these would subtract to what, a 2? So if I had a 3 right here, then these two would easily go to 0. So if I multiply this bottom equation by 3, then I would have the 3 that we'd like in front of that y. So I'm going to keep the first one the same. 2x plus 3y equals -5, and then times by 3. 9x minus 3y equals 13 times 3, 13. I can't do that in my head all of a sudden. It's like all I could get was the 2, so 39. Okay, now I can do a big addition problem. Those cancel or eliminate, and 9 plus 2 is 11x equals 39 minus 5 is 34. Okay, that's not very pretty. X equals 34/11. Ew. So two things I can do. I can still substitute that back in, or I could do elimination twice, eliminating the x's. Really up to you. So I'm going to put this back into this equation here, only because it doesn't have fractions, and so it looks easier. So 2 times 34/11 plus 3y equals -5. So when I times these, think of this as 2 over 1. So 34 times 2 is 68/11. I feel like I mean, I assume it has a fraction answer, but I feel like I might have missed something, but I don't think I did. I don't think I made any mistakes. Okay, so then from here, we're at 68/11 has to be subtracted over to the other side. So it's -5 minus 68/11. So I'm going to do that in the calculator, -5, because you need a common denominator. So you'd have to times and get 55/11, and then 55, -55 minus 68 was be adding them over 11. So -5 minus 68/11. So I should get -123/11. So I'm going to have 3y equals -123/11. And then we have to divide by 3. divide by 3. And when I divide by 3, that's the same as flipping and multiplying. So I could, instead of writing it like this, I could write it as times 1/3, because that makes more sense to me. So we would have 123 over 33. And this is y. So x, y. Ew, fractions. Okay, 18 is the same idea, but I'm not going to do the whole thing. But what would I multiply the top equation by? Goodness, they did the same on both. Oh, well, it's usually not like that. That's just probably the way they set it up. So if I'm looking at this, what would I multiply this top equation by to get rid of that 2 and that 3? Times them. What's 2 times 3? 6. Multiply by 6. Okay, and the bottom one's the same. Okay, so let's look at some word problems. Suppose the supply and demand for posters of the 2013 Super Bowl champions for a particular week are given as the supply is here, demand is here, where P is the price in dollars and Q is the quantity in thousands. Find the supply and demand to the nearest unit if the posters are priced at $6. So find the supply. So we're just looking at our supply equation if they're priced at $6. So our price was P. So we would have 6 equals the 0.8 Q plus 2.6, and we'd have to solve that one. So we'd subtract the 2.6 over. So far, we haven't had to use systems of equations yet. So 6 minus 2.6 is 3.4 equals 0.8 Q. Then divide by 0.8, and I get 4.25 equals the quantity. So about 4, can't really make 1/4 of a poster. I mean, you could try, but I don't think someone would want to buy it. Okay, find the supply and demand if we're supposed to do supply and demand? Oh, we are, sorry. This is supply. We were supposed to on this one too. So let's do demand over here. So the demand would be $6 equals negative 1.2 Q plus 9. So minus my 9, I get 3 equals negative 1.2 Q. So 3 divided by negative 1.2 is a negative. Our quantity is negative. That's not good. Our quantity is negative. Okay, so I was like, so the next part asks the same thing with different. I was like, I wonder if that just is, I know, I mean, we're only making 4 posters, but I was like, that just doesn't seem right. Oh, shoot. This should have been a negative, and that would have been a positive. Okay, I see it. I didn't see it till I looked at my work because I was like, why would they give a demand of negative? That means there's no demand, right? You can't have a demand of negative. Okay, so then let's do the same thing at $8. See what the quantity is and the demand, or supply and demand. So $8 equals the 0.8 Q plus 2.6. So we'll solve that. So I'm going to take in my calculator 8 minus 2.6, and I got 5.4 equals the 0.8 Q. So divide by 0.8, and it's 6.75 equals the quantity. And then the demand at $8 equals the negative 1.2 Q plus 9. So I minus the 9 over, And this time I'll make sure to write my -1 equals -1.2q. So -1 divided by -1.2 is going to be a decimal of about 0.8333 equals q. So what does that tell me? It tells me as the price goes up, your demand goes down. Okay. So, and your supply, I don't know what else to say about supply. Your supply is, if they're charged $8, your supply goes up. Basically, if you're making more money, you can make more supply, right? But people don't want to buy it. So you have to find the right price and to make the supply, but still meet the demand. This is a huge issue. If you buy too much stuff and no one wants to buy them, your business won't make it, right? So you can see where we're going with this. So then now, what if we want to know an equilibrium between price and quantity? What is the break even idea, right? So if I see equilibrium, break even, I need a system of equations. Where does supply and demand equal each other? So I'm going to make exactly enough items for the people that'll buy them at exactly the right price. Okay, so then we go all the way back up, and we're going to use these two equations here to find our system of equations. So they're both P equals. So what I could do is for the supply, which was 0.8Q plus 2.6, I can substitute that in and have the -1.2Q plus 9. So basically, I substituted one equation in for P. So I love substitution when they're both Y equals or P equals, which happens kind of a lot in business. Okay, so let's solve this. So I'm going to add the 1.2 over. Okay, so 0.8 plus 1.2Q is 2Qs plus the 2.6 equals 9 minus the 2.6 over. So 9 minus 2.6 is 6.4. And then divide that by 2. And I got Q is equal to 3.2. Okay, let's substitute that back into either equation. So we could go P is equal to 0.8 times 3.2 plus 2.6. That was the one that had all the positives. Excuse me. 0.8 times 3.2 plus 2.6 is 5.16. So we're going to charge $5, right? For a quantity of 3.2. Seems a little low, but there you go. Okay. So 20. At $1.40 per pound, a daily supply of tobacco, is this old? I mean, I guess people still smoke tobacco, is 1,075 pounds, and the daily demand is 580 pounds. When the price falls from $1.20 per pound and the daily supply decreases to 575 pounds and the daily demand increases to 980, oh, what is our supply equation? Okay, so where am I going to even start with this one? Well, I have to look at the 2 points. So people don't always think of this one, this point idea. So I'm going to think of it as for supply, it was 175 pounds to $1.40. Okay, so price and supply. And then we had, what was the other one? 575 with $1.20. So think of it like this. This is a point, 1,075, $1.40. And then our demand was 575 and $1.20. This method is used a lot in business because we have 2 sample points that we could then write our equation to estimate the future. So this method is all the time method. Sorry, I worked out this morning and I cannot seem to get myself from stop coughing. But I'm probably the only teacher that doesn't believe in just, starting over on your video if you have to cough or something. I'm like, no, it's real life. Okay, so then let's find our slopes. We have to find the equation of our line, right? So we start with slope, which is y minus y. So we could go either way. So $1.40 minus $1.20, y minus y, over x minus x. How much money am I spending per pound of tobacco? So then I get 0.2 over 500. Okay, and if I divide that, it's like 0.0004. So pretty small slope. Okay, and then I can use my point slope equation. So remember that one goes y minus y1 equals m times x minus x1. And we put one of the points in and that slope we found. So y minus, if we just use the first point, it was $1.40 equals our slope is 0.0004 times x minus 1,075. So we can simplify this equation or we can leave it like this, like we're done. But usually we want to put it in y equals form. And so I'm going to distribute this and I would get 0.0004x. And then I got to sneak my calculator, times 1075 is 43. So minus 0.43 when I times those two together. And then I have to add over this $1.40. Has to only go to the number at the end, right? So I'll just put my answer on this side. So I'm going to get y equals 0.0004x, and then negative 0.43 plus $1.40 is going to be a positive 97 cents. Okay, that's our supply demand equation. And really, y is equal to price. So you could have done a P if you wanted, and X is equal to pounds of tobacco. Okay, and you could look back and see that from your points, because this is X and this is Y, and that was our pounds of tobacco and the money. What about demand? So we do the same thing for demand. Okay, so at $1.40, our demand was $5.80, and at $1.20, our demand was $4.90 or $4.80, $9.80. Let's write those equations. So 580 or points, excuse me, to get the equation is at $1.40, and 980 at $1.20. Okay, so there we are. See how we got those points? They were all about demand at that price. And we could do the same thing, find our slope, write our equation of our line, and we better end up with y equals negative 0.0005 x plus $1.69, according to my notes. So we can, from there, find our two ugly equations. So what I want to do next is find the equilibrium. Where are these equal? Well, they're pretty easy to solve for because they're both y equals. So I can say negative 0.1235x plus $1.69, which I hope I did that right when I did my notes, right? Equals the 0.0004 x plus 97 cents. So I just set them equal to each other to get that equilibrium, to get rid of the y, or so that I can find x, and then I substitute it back in. So let's solve this. If I add the 0.0005 the other way, it stays positive, but either way would work. So 0.1234 plus 0.0005 is 9. Oh, I put it in, I wish I could show you that. That's okay. So we're here at $1.69 equals, it put it in scientific notation. I don't know why, it's only a couple numbers. So it says 9e negative 4. So that means right now you have a 9 and you need to move the decimal 4 places. So that adds 3 zeros and a 9, which means 5 plus 4 is 9, and it stayed in that same place. But I'm just trying to explain, and it should be positive, how if it puts it in scientific notation, that 4 means negative 4, move it to the left 4 places. Move your decimal to the left 4 places. Okay, then we're going to move that 0.97 cents, so $1.69 minus 97 cents is 72 cents equals this. So 72 cents divided by 0.1239 is 800. Okay, wow, so X is 800. X is our pounds of tobacco. Okay, put your X back into either equation. So I have a little room over here. I'll just do it over here. So I can put it back into this one, negative 0.0005 times 800 plus $1.69 equals our Y value. Okay, so I'm just going to plug that in my calculator. Negative 0.1235 times the 800 plus $1.69 is $1.29. So $1.29, that's money, and this is pounds. I should just do LBs, right? LBs, pounds. So I couldn't get any uglier on that LB. There we go. LBs. Okay, so 800, these are our two answers for equilibrium. So if we go up, what we should do, so it's in between our $1.40 and our $1.20, so we can see it's $1.29, and the 800 is in between the other two as well, the 1,075 and the 580. So we can kind of see that the equilibrium is in between there. But there you go. Equilibrium is probably where you should go, right? Because that's where our supply and our demand are equal. Hopefully this was helpful. You have other systems of equations that can be a little tricky on setting them up. Let me know if you get stuck on any of them. I'd be happy to help.